for, okay. So, little background information. I'm a student at UCT. I'm currently studying actuarial sciences. So I matriculated 2023. So that was about 2 years. No, 2022. Sorry. So that was 2 years ago now. Okay. What we're going to be starting with today is just a brief introduction on patterns and sequences. Okay. So for today, we're just going to stick with sequences. Give a brief overview, kind of like a revision workshop, and then we'll get started with series in our next lecture. All right, but we're just going to start with sequences for today. So let me just try share my screen. Share screen. Share. Okay. Start with. Okay, can everyone see my screen? Thumbs up if you can see my screen. Okay. Okay, guys, so as I said, patterns, sequences, and series. Let's do this in view mode. Okay, patterns, sequences, and series. Now, as I said before, guys, today I'm just going to be focusing on patterns, give a brief overview. I know you guys did this in grade 11. I'm not sure about grade 10 as well, but I want to start with patterns today because they do show up in every paper one of both the prelims and the final. Okay, so it's something that you want to nail, something that you want to get down. And it builds onto sequences as well. So it's good to have that strong foundation. Okay, so we're gonna have a brief summary, quick summary. So sequences. Okay, so we have three main types of sequences that we're going to be talking about today. That is arithmetic sequences, your geometric sequences, and then your quadratic sequences. We're also going to be talking about the differences between the different types of sequences and the properties and characteristics of each kind of sequence. And then towards the end, kind of going to go through a couple of examples. And then the last example is a little bit of a tricky one, but they love throwing those in the exam papers. So we'll go through that as well. Okay. And guys, if you have a question, I don't know if there's a way that you guys can like maybe just in the chat room, I'll keep every 5 minutes or so, I'll keep going onto this tab and then check if there are any questions. Maybe you guys want me to stop, slow down, go through something that you're not quite sure about. So feel free to ask, guys. Okay. So let's start with our first type of sequence. We have arithmetic sequences. So arithmetic sequences are a sequence in which the difference between any two consecutive terms is some constant number d. Okay, now the nth term of our arithmetic sequences, or the formula for arithmetic sequences, is given as Tn is equal to a plus n minus 1 times d, where a is the value of the first term, n is the total number of terms, and then d is the constant difference between terms. This one was nice and easy. I think this is the first type of sequence that you guys learned. Okay, so for example, given the sequence 5, 8, 11, 14, 17, and 20. Okay, from this, we know that a is the value of our first term. This is 5. Okay, n is the total number of terms. There are 6 terms here. And then d is a constant difference. And you can work this out by taking one term and then subtracting the term just before that. So Tn plus 1 minus Tn. So for example, 8 minus 5, that's 3. 11 minus 8, that's 3, so on and so forth. Okay, so nice thing to remember about arithmetic sequences is that there is a constant difference. And then we move over to our second type of sequence, which is our geometric sequences. Now, a geometric sequence is a sequence in which the difference between any two consecutive terms is characterized by some ratio r. That's just a fancy way of saying the difference between one term and the next is some ratio. Okay, so Remember, in with our arithmetic sequences, the difference between any two terms was some constant that we were adding or subtracting. Now, with geometric sequences, the difference between any two terms is a ratio, meaning we're multiplying by some factor r. Okay, so Tn, the general term, is given as Tn is equal to AR to the power of n minus 1. This arrow over here it represents to the power. So whenever you see this arrow, just know that whatever follows is a power. Okay, so AR to the power of n minus 1, where A is still value of the first term, and then R is the ratio. Okay, n is the total number of terms. No, sorry, A is not the value of the first term with geometric sequences. That was just arithmetic sequences only. So if R is the ratio, and then n is the number of terms. Now, how do we get R? R can be given as Tn over Tn minus 1. Now, what does this mean? This means that R, for any given geometric sequence, we can find R by taking some term and dividing it by the term just before that. So for example, we could take 14 and divide it by 7. We could take 28 and divide it by 14, and we could take 56 and divide it by 28. That should all give us some constant ratio R. So our n is the number of terms we have here. We have 6 terms. R, as I said, could be one term divided by the term just before that, and it is 2. Okay, so that is it for geometric sequences. Let me just see if anyone has a question. Oh, okay, yes. Okay. Is everyone following? Am I not moving too fast? Just give me a thumbs up if the pace is okay. Maybe something you want me to go through again. Thumbs up, guys, please. Okay, I don't think. Okay, I don't see any questions, so I'll move on. Okay, and the last type of sequence we're going to go through today is our quadratic sequence. Now, quadratic sequence is a sequence that is characterized by a constant second difference. Now, do not confuse this with arithmetic sequences. Arithmetic sequences, it was a constant first difference. Now, with quadratic sequences, it's a constant second difference. Now, the general term for quadratic sequence is given as Tn is equal to an squared plus bn plus c. Okay, now we have A, B, and C. These are our coefficients of our term. Now, how do we derive these coefficients? How do we get the value for A? How do we get the value for B? And how do we get the value for C? Right. Now, a nice little shortcut formula to work out these coefficients is 2A is equal to my second difference, 3A plus B is equal to my first difference, and A plus B plus C is equal to the first term. Now, what does this mean? I'm going to use a quick example to show you what I mean here. So let's take this quadratic sequence over here. We have 8, 19, 34, and 53. Now, the first differences between these terms is 11, 15, and 19. Now, I found these differences by taking, obviously, the term and subtracting the term just before it. Now, the second constant difference is 15 minus 11, that's 4. 19 minus 15, that gives me 4 as well. Now, I said that to work out what my A coefficient is, I will say 2A is equal to the first term of the first constant difference. Sorry, this should be first. These are swapped. Okay, let me say edit. Editing. 2A first. No, sorry, these are correct. These are correct, guys. My bad. Okay, so 2A is my second difference. So I say 2A is equal to my second difference. Second constant difference is 4, and I get my A coefficient, which is then equal to 2. So that's my A value, 2. Okay, 3A plus B is my first term of my first difference. So I say 3A plus B is equal to 11. 11 is the first term of the first difference, but I know what the value of my A is because I worked it out just before. So I subs in the 2 there to get 6 plus b is equal to 11. That enables me to get my b coefficient, which is then equal to 5. And then finally, a plus b plus c is equal to my first term. I know what my a value is. It is 2. I know what my b value is. It was 5. So 2 plus 5 plus c is equal to 8. You can then quickly work that out to get c is equal to 1. All right. Therefore, for this term, if they ask you for the nth term, right, or the formula for this term, it would be simply given as Tn is equal to 2n squared plus 5n plus 1. Okay, so this shortcut over here, I know some people like to use the simultaneous equations. For me, I think especially when you're in an exam or a test, this method is nice and easy. It's very quick. You just remember 2a is equal to my second difference. 3a plus b is equal to my first difference. A plus b plus c is equal to the first term. You calculate your a coefficient, your b coefficient, your c coefficient, and that will then give you the general term. Okay, so we're going to do some examples now. So guys, let me just see if anyone has a question. Okay, no questions. Okay. Now what we're going to do, guys, I hope you have I don't know, pencil or paper. So I'm going to go through some examples. What I'm going to do, I'm going to read the examples out, give you like 5 or 6 minutes to try work it out or to try think about what you would do. I'll then go through the answer. I will type out the answer on this file, and then you will see how I get to the answer. So we'll go through it together. So I'll read the question, give you a few minutes to think about it, maybe work it out if you want to, and then we'll go through the question. Okay. So the first question is given the sequence 7, 12, 17, and 22. Determine the value of the 91th term. B, calculate the value for which Tn is equal to 517. Okay, so I'll give you guys like 5 minutes to try work that out quickly and then see what answers you come up with. Let me just put the file in viewing mode so you can see it better. Okay, viewing, it is in viewing. Let's see if I can make this better. Okay, guys, 2 more minutes. Okay, so I'm gonna go through the solution quickly. I'm gonna do it together. Okay. So this was question 1. So they gave me the sequence 7, 12, 17, and 22. And the first question was to determine the value of the 91st term. Now, we can't determine the value of the 91st term without determining the nth general term, so the formula for the sequence. Okay, so I know that, first of all, this is, okay. I know that there's a constant difference because if I take the 12, subtract the 7, that is a constant difference. 17 minus the 12, that is a constant difference. And 22 minus 17, that is a constant difference. It's the constant difference of 5. So my general term is given as Tn is equal to A plus n minus 1 times some constant difference D. All right. Now it already established that my A is the value of my first term. This is equal to 7. All right. My D is the constant difference, and this is given as 5, as I worked out. So this then enables me to derive the general term. So the general term is given as Tn is equal to A7 plus n minus 1 times a constant difference of 5. Now, some people, they won't penalize this for you. You can leave it in this form, or you can simplify by multiplying these two brackets together. Either way is simple. Because you guys are not allowed calculators, I do recommend simplifying this. So the simplified version of this, if you multiply the brackets out, get that Tn is equal to 5n plus 2. So this is the general term if you simplify out these brackets, okay? If the question does ask that you leave your answer in simplified form, just do maybe simplify the term to give them the simplified general term. So this is our general term right here, 5n plus 2. Now the question was to determine the value of the 91st term, so T91. So we substitute the 91 into the n to work that out. So T91 591 plus 2. And this is equal to, grab our calculator. That will give you 457. So if you got 457 for the first part, you are correct. So now let's look at the second question, the second part of that question. So B, it states that calculate the value for which Tn is equal to 517. Okay. Now with this question, there's something that I want to highlight quickly. I know that sometimes people get confused between, are they asking me for n? Are they asking me for Tn? Guys, n is a particular, it is a term, okay? The number of that term. So if they're asking for the fifth term, it's n equals 5, right? The fourth term, n equals 4. N is telling me which term I'm working with, all right? Tn is telling me the value of that term. So for the first question, they asked me for the value of T91, all right? Meaning n is 91. Basically, they're asking me for the value of the 91st term, all right? What is Tn when n is equal to 91? So whenever you see something along the lines of value, that is your keyword, value. Let me highlight it. Value. Okay, whenever you see the word value, you know they're asking you for Tn. All right. Okay. And then now they're asking, calculate the value. Okay, let me use another word. Term. Okay. Calculate the term for which Tn is equal to 517. So they've told me what the value of this term is. It's 517. Now they're asking me which term is equal to 517. So what we're looking for, we're looking for our n. Okay, so start here. Okay, so remember our general term was given as Tn is equal to 5n plus 2. Therefore, they tell me that the value of this term is now 517. So 517 is equal to 5 times some n value that we're looking for plus 2. When you work it out, you get that n is equal to 103. Okay. Now it's important to make that distinction, guys. I've seen a lot of people make mistakes. You lose silly marks over confusing. Are they asking me for N? Are they asking me for TN? So always just remember that when they're asking you, when you're trying to find which term, that is the N. And when you're trying to find what is the value of this particular term that I've been giving, that is TN that they're asking you to work out. Okay. And then we're going to go through the second question. So the second question is a quadratic sequence. The rest of these questions actually focus on the quadratics because that is where the most marks is. They love asking questions about the quadratic sequences. So consider the quadratic sequence below. We have 2, 3, 10, and 23. So the questions read A, write down the next term. B, determine the nth term. So that's another way of saying the formula for this term, and then calculate the 20th term of the sequence. Let me use our keyword there, value, and then see if you guys remember what value means. Right, to calculate the value of the 20th term of the sequence. So I'm going to give you 5 minutes to work out A. We'll go through A, another few minutes to go through B, and another few minutes to go through C. So just so you guys have time to quickly think about the question and then see if you can do it on your own, and then if not, where you're going wrong and if we can correct that. So guys, please attempt A. I will give you 5 minutes. So just write down the value of the next term. So what comes after 23? Put in viewing mode for you guys. Okay, this is a bit of a longer one, so I'll give you another 3 minutes to work it out. It does take some time. Okay, guys, let's go through the question. So we're given the quadratic sequence 2, 3, 10, and 23, and they're asking us to write down the value of the next term. So what comes after 23? Okay, so let's go through it together. So let's go out of editing mode. Let's go into editing. Okay. So this is number 2, 2A. Okay. So the sequence I was given, guys, was 2, 3, 10, 23. And they're asking me for the value of the next term. Let's make these spaces bigger so you guys can see what's going on. Okay. Now, the best way to approach questions like this, it doesn't matter if they're asking you for the value of the next term, the constant difference, whatever question it is, whenever you see the term quadratic sequence and they give you a few of the first terms, you want to write down the sets of the first differences and the sets of the second constant differences. Everything and anything you will need with these kinds of questions, with any question related to quadratic sequences, it will come from looking at the terms that they give you and then looking at the first differences, looking at the second differences. So we can quickly write down our first set of differences here. Okay. Let me do it in color so you guys can see. We'll do purple. Okay. So 2 and 3. All right. The difference between 2 and 3 is 1. All right. And then the second term, 10 minus 3, that is 7. And then 23 minus 10, that is 13. Okay, so these are my first differences. Let me put an arrow here. First differences. Okay, and then I want to go ahead and put in my second constant differences as well. So we'll do that in another color. So 7 minus 1, that is 6. And because it's constant, I know it will be 6 throughout. So even if I had 20 terms, the second difference is always constant. So it will be 6 throughout. 6. These are my second but constant differences. Okay, now let me put these to the side because we're going to need these. Okay, so I want to work out what the next term is. This is like a pyramid, so I want to start at the bottom. So the This second difference is always constant, so I know that this is going to be 6 as well. Meaning, from this 13, to get the fourth term of the first differences, I'm going to add 6. So 13 plus 6, that will then give me 19. 19. Okay. So I took my constant difference, and then this term here was 13. So I took the 13, I added the 6, which is a constant difference, to get 19. So 19 is the next term in this set of first differences. Okay. I then go to my first set of terms, and the last number that I have is 23. To get the next term from 23, I simply add the 19, which is the next first difference, and that will give me 42. So if you guys got 42 over there, you're correct. And that is how we work that out. Okay. So I cannot emphasize this enough, guys. This little pyramid diagram that we've done over here with our first set of terms, our first differences, and our second constant difference, when you're working with quadratic sequences, that is all you need to answer any question that they can give you. Okay. So let's read the second part of this question. Okay, B. Now determine the nth term or the formula of the sequence. Okay, so now they want the formula of this sequence over here. Okay, oh yes, yes. I will give you guys another 3 minutes to try get the formula. So we have the foundation over here, and I'll give you guys 3 minutes to try derive the nth term of this quadratic sequence. I'll put in view mode for you guys again. Okay, one more minute, guys. Okay, guys, let's go through the question together. So we're trying to derive the nth general term or the formula of this quadratic sequence over here. Okay. Okay. So I know that the general term of a quadratic formula can be given as Tn is equal to An squared plus Bn plus C. All right. So we're trying to work out what our A value is, what our B value is, and what our C value is. All right. But remember, we had our shortcut formula where 2A is equal to the first, 2A is equal to the second constant difference, and 3A plus B was equal to the first term of the first difference. And then A plus B plus C was equal to my first term. Okay. Shortcut formula, guys. Nice and easy. Easy marks. You apply this, you're guaranteed to get the marks, guys. Okay, so 2A is equal to, my second constant difference for this was 6. So 2A is equal to 6. Therefore, A is equal to 3. Right. And then it was also given that 3A plus B is equal to, the first term of my first difference is 1. All right. But we know that we've already worked out our A value, so we can then substitute that into this to get that 6 plus B is equal to 1. All right. Therefore, the value of our B is equal to minus 5. All right. And then last but not least, A plus B plus C was equal to my first term, and my first term was 2. All right, but we've already worked out what the value of A is. It was 3. We've already worked out what the value of B was. It was minus 5. So we should say minus 5. 3 minus 5 plus C, and that will give me the value of the first term, which is 2, pardon me, equal to 2. Quick algebra, guys, you get C is equal to 7. All right, that then enables me to derive my nth term. So my nth term will then be equal to Tn is equal to A 3n squared plus my B was minus 8 n plus my C value, we got 7. All right, so that's how we derive the nth term, guys. So let's go through the steps that we've taken so far. First of all, we derive our first differences and our second constant differences. We then use our shortcut formula to get our coefficients for A, B, and C, and that then enables us to derive our nth general term. Sorry, did I say minus 8? Yeah, this is a mistake, sorry. Minus 5. So B, wait, A, 6 over 2, 3. Oh, sorry, pardon me, guys, I made a mistake. This is supposed to be 3, 6, 9. 9 minus 8, that is minus 8. Sorry, guys, that is my mistake. Okay, it's minus 8. Okay, now see. Yes. Okay, so our A value is 3, our B value is minus 8, and our C value is 7. That's how we derive the nth general term, guys. Okay, I see we don't have any questions. Okay, let's move on. Now, the last part of the question, C, asks us to calculate the value of the 20th term of the sequence. Remember what I said about value, guys, difference between Tn and n. So this is nice and quick. I'll give you guys 2 minutes to try work out what the value of the 20th term of the sequence is. Okay, maybe this is easier. So this is our general term, and you're trying to work out what the value of the 20th term is. Okay, so this one is nice and short. We just plug in 20 into our n. All right, so T20 is simply equal to 3 times 20 squared plus minus 8 times 20 plus 7. And that should give me 3 times 20 squared minus 8, 20 plus 7. That should give me 1047. So if you got 1047, you're correct, guys. It's equal to 1047. All right. So just to reiterate, they asked me for the value of the 20th term. They're telling me that the n is 20. I'm working with my 20th term, and I want to know what the 20th term in this sequence is. And that is 1047. Okay. And then number 3, we have the question, calculate which term of the sequence 35, 28, 21 will have a value of minus 140. Let me specify that this term, this is an arithmetic sequence. So which term of the arithmetic sequence 35, 28, 21 will have a value of minus 140? So again, I'll give you guys 3 minutes to try work that out quickly. Remember, first step, try to derive the nth term, and then try plug in whatever you need to plug in to see which value will give you minus 140. One more minute, guys. Okay, let's go through the answers together, guys. So we're given this arithmetic term 35, 28, 21. And the first step, as always the first step, we want to derive the nth general term. So because it's arithmetic, I know that Tn will be equal to A plus n minus 1 times D. All right. Now, what is the value of our A term? A here A was given as 35. So A is equal to 35. And then the constant different D, we can work that out by taking, we can take 28, subtract it from 35, or we can take 21 and subtract it from 28, whichever one you want, guys. It'll give you the same answer. And if we put that into our calculators, we'll get a value of -7. So that is the constant difference between each term. They're subtracting -7 each time. D is equal to -7. Now we have enough information to derive our nth general term. So Tn is equal to 35 plus n minus 1 times our constant difference, which is -7. Again, if they ask you to simplify, you can simplify this. If they don't, you can leave it in this form. It's the same thing. Okay. Now, the question is asking us which value, which term in the sequence that we've been given is going to give us a value of -140. All right. So the value Tn they've given us is -140, and we want to work out what our n will be. All right. So which term has a value of -140? So we simply substitute the -140 into our Tn. -140 is equal to 35 plus n minus 1 times -7. You could put that in your calculator quickly. And you should get an answer of 26. So the value of our 26th term in the sequence is equal to our n. Or the value of our 26th term in the sequence is equal to -140. So that's our answer there, guys. And then I want to do one more question. This one is a bit of a more challenging question, but with the previous questions, we've kind of built a foundational basis on attacking sequence-related questions. So we've established that whenever we're answering a question, whether it be arithmetic sequences, geometric sequences, quadratic sequences, the first and best thing that we can always do for ourselves is to derive the nth generation to do so. Because once we have the nth general term, that is then the basis upon which we can answer any other question related to the sequence. Okay, so I did put an asterisk at number 4 because it is a bit of a more higher level question. So number 4 reads, the following information is given about a quadratic sequence. They tell me that the first term is equal to 3. The difference between the first and second terms is equal to 9. And the difference between the third and second terms is equal to 21. Now, A states or asks us to show that the value of the fifth term is equal to 111. B show that the general term Tn can be given as Tn is equals 6n squared minus 9n plus 6. And then C, show that the pattern is increasing for all n is an element of natural numbers. So for all natural numbers n, show that this pattern is increasing, constantly getting bigger. Okay, so I will give you guys 5 minutes to work out A. So try show that the value of the fifth term is 111. Okay, another 2 minutes, guys. Okay, let's start attacking this question, guys. So this one is a bit of a higher order question. We'll start with A. Show that T5, the value of the fifth term, is 111. Okay, I'm going to remove this. Okay, now with this question, guys, always look at the information. Everything and anything we need is in the information that they've given us. So for this question, they've told us that the value of the first term is equal to 3. So I can start there. 3. That's all I know. The value of the first term is equal to 3. I also know that the difference between the first term and the second term is equal to 9. Okay. So I can put 9 just beneath the 3. Put that in one color, or purple. 9. Then the final piece of information they give me is that the difference between the second and the third term is 21. So I know that whatever follows this 9 is 21. Okay. Now, because the difference between the first and the second term is 9, I know that to derive the second term, I can simply add 9 to 3. And that will give me 12. Okay, but they've also given me the difference between the second and third term. Now to get the third term, I can add 21 to the 12, and that will give me 33. Okay, so we have 3 terms so far, but they're asking me to derive the 5th term, all right, what the value of T5 is. Now, with the information that I have enough to derive all the terms until infinity, because I have the first difference, and I have the actual term itself. From the first difference, I can derive the second difference. Okay, so I know the difference between 9 and 21. I subtract 9 from 21, and that will give me 12. So we'll put this 12 here, and another color, 12. So the constant difference on every second difference is 12. Okay. So now I'm going to focus on my first difference here, the ones in purple. Okay, I have 9, I have 21. I know that the difference between 9 and 21 is 12, and that 12 is a constant difference amongst these first terms. So to get the third term of my first differences, I'm simply going to add 12 to 21. And that will give me 33. But I know that the constant differences are constant. So to get the next term after 33 as well, I'll add 12 again, and that should give me 45. And net again, from 45 to get the next one, I add 12 again, and that will give me 57. We'll stop there for now. And then we can fill out our constant differences over here. So we know it'll always be 12. Between these numbers, it'll always be 12. Let me make these bigger. Okay, now we can attempt to work out the values, the next terms in our original term. Okay, so I have 33 here. To get to the value of the fourth term, it'll be 33 plus 33, that'll give me 66. Okay, and to work out the value of the fifth term, which is what they asked me for, I'll take the 66 and I'll add 45, and that will give me 111. So that's how you work out the question, guys. This is the value that they were looking for. This is the value of my fifth term, and it is 111. Okay. So what we did for this question, we took the information that they gave us and the characteristics of the quadratic sequences to then work out a full picture of what my sequence looks like. So they told me that the value of my first term was 3. They also told me that the difference between the second term and the first term was 9, and the difference between the third and second terms was 21. And that was all the information I needed to then work out what my second constant difference is. And from that second constant difference, I could finish up the terms in our purple first differences over here. And from that, I could then add those to the first terms to work out what the value of the fifth term is. We could have worked out what the value of the millionth term, 1,000, whatever it is. We had enough information to continue all the way to infinity. Okay. So the name of the game here was knowing the characteristics of your quadratic sequences and using all the information that they've given you. Okay. I know it is a cliche, but it is a big hint to always look at the question. All right. They will never tell you something for nothing. All the information that they give in a question, 9 times out of 10, needs to be used in order to figure out what the answer is or what it is they're asking you to do. Okay. So that was part A of this question. Let's now look at part B. show that the general term Tn can be given as Tn is equal to 6n squared minus 9n plus 6. At this point, we've done this quite a bit before, so I'm only going to give you guys 2 minutes to quickly try and work that out or think about the answer. So from this over here, from our framework over here with our first difference and our second difference, try to derive the general term. And as a quick reminder, I'll write down what the general term is for quadratics. Tn is equal to an plus c. Okay, let's derive the general term, guys. So as always, we use our trusty shortcut formula. We know that 2a is going to be the value of my second constant difference, that's 12. Therefore, my a value is going to be equal to 6. Okay. I also know that 3a plus b should give me my first term of my first differences, which is 9. But I already know what the a value is, which is 6. So subs in the 6 into the a there to get that 18 plus b is equal to 9. And that enables me to work out my b value. And b will simply be 9 minus 18, which is just minus 9. So b is equal to minus 9. Okay, and then to work out c, we know the c is a plus b plus c will give me the value of my first term. So let's add a new window over here. Okay. So a plus b plus c give me the value of my first term, which is equal to 3. All right, we already worked out our a was. Our a was 6. Our b was minus 9. So 6 minus 9 plus c should give me 3. Okay, and a little bit of quick algebra there. Get that 6 minus 9 plus our x value. Give me 3. We should get that our c value is positive 6. So we have all our coefficients. We have a, we have b, and our c. We can then put them together to derive our nth general term. So therefore, Tn given as, so the a was 6. N squared Our B was -9. So we can simply put a minus there. -9n. And our C was 6 plus 6 is our nth general term. Now let's check if our nth general term that we've derived is the same as the one they asked in the question. Yes, so 6n squared minus 9n plus 6. So we are correct. We derived the same nth general term as the one given in the question. So we've proved that this is indeed correct. Now C, show that the pattern is increasing for all n is an element of natural integers, natural numbers, pardon me. So in simple terms, they're asking us to show that this pattern that we've been given over here, this pattern that we've worked out, will always be increasing. So the next number after 42 will be greater than 42. And the next number after that will be greater. And next number after that will be greater. For all n, how do we show that this pattern will always be increasing? I'll give you guys some time to kind of think about it, maybe come up with an idea, think of how you would approach this question and the methods that you would take to try and show that this pattern is always increasing. I'll give you guys 3 minutes. So again, show that this pattern is always increasing. Okay, let's attempt this question, guys. So we want to know, how do we show that this pattern will always be increasing for whatever n value or n number of terms that we may have? Whether n is 100, a million, how do we show that this pattern will always be increasing? Okay, now the hint for this question is to look at our first differences, to derive a general term for our first differences. Now, when we have quadratic sequences, our first differences will always make an arithmetic sequence. Okay, so our first differences will always make an arithmetic sequences. So we can derive a formula for our first differences because we know what the formula for an arithmetic sequence is. Okay, so this is for C, I believe. C. Okay, now Tn is equal to A plus n minus 1 times D. Okay, so this is our formula for an arithmetic sequence. From our first differences, we know that A is the value of the first term, which is equal to 1. Okay. We know that D is our constant difference, and our constant difference is 6. So we can take the 7, subtract the 1, 13, subtract the 7. It'll always be a constant difference of 6. That gives us enough to derive a general formula for our arithmetic sequence. Let's say that Tn is equal to A, which is 1, plus n minus 1 times our constant difference, which is 6. Now, for this question, it is advisable. It makes things easier to work with the simplified version of our arithmetic sequence. Okay, so we're going to simplify this, substitute in, multiply the 6 out into the brackets, and then simplify this. When simplified, okay, Tn is equal to 1 plus 6n minus 6. And when we simplify that, we get that Tn is equal to 6n minus 5. Okay, so that is our general term for this sequence. Okay, 6n minus 5. Okay, now the question is asking me to prove that this will always be an increasing pattern. Now, to show that this will always be an increasing pattern, and when I say this, I mean the quadratic sequence itself. So the 2, 3, 10, 23, and 42, etc., etc. I need to show that the first differences will always be positive, meaning for any n will always be greater than 0 for my first set of differences. So what I do is I take the formula or the nth term for my first differences, and I use an inequality to show for what values of n will this first difference, our arithmetic sequence, always be greater than 0. Okay, so let me just type out what I mean. What we want to see is if 6n, for what values of 6n minus 5 will that always be greater than 0? If n is negative, then it doesn't mean that it means that our pattern is not always increasing for all positive n, or for all n which is an element of the natural numbers. If n, however, is greater than or equal to 0, then it means that our pattern is always increasing for n whenever n is any form of a natural number. Okay, so let's quickly work out this inequality. Okay, so we have that 6n minus 5 is greater than 0. Minus 5 is greater than 0. We can take the 5 over to the other side. 6n is greater than 5. Obviously, the size will change. And then n is greater than 5 over 6. N greater than 5 over 6. Great. Now that means the lowest possible value that our n will take is always greater than 5 over 6. N will never be less than or equal to 5 over 6. Meaning, we can then conclude from that therefore our quadratic sequence will always be increasing for any natural number n. And we showed this by showing that our first set of differences, our arithmetic sequence, will always be positive. Okay, so n will always be greater than 5 over 6. Alternatively, for this question, you could have simply stated that Since the last term that we have here is 42, and our first differences are always increasing by a positive b. All right, so our constant difference was 6. That means the first differences will always be positive, and when you add a positive to a positive, that number keeps on getting bigger. So we could have simply showed that since our second constant differences are 6, when we add 6 to 19, we get 25. And we add 25 to 42, you'll get a number that is greater and that is constantly increasing. And if you keep on repeating that process, our pattern will get bigger and bigger and bigger. And that is true because 3 is greater than 2, 10 is greater than 3, 23 is greater than 10, and 42 is greater than 23. And since our constant difference is 6 and our arithmetic sequence is increasing by a positive constant difference, that means our quadratic sequence will also increase by a positive difference as well, meaning our pattern is always increasing. Okay, so that was a bit of a kind of a level 3-ish question. They love throwing those in there. Okay, so again, with questions like this, guys, read the question, look at the information that they're giving you, analyze what it is they're asking you to do, and how can we use our foundation? How can we use what we know about sequences to try and work out this question or whatever question they may give us? Okay. Oh, there was a question. Are we doing that for question 4 or question 2? That should have been for question 4, if I'm not mistaken. I'm not sure if I maybe made a mistake over there. Sorry, guys, I'm not sure if I made a mistake there, but this should have been for question 4. The C applies to question 4. I'm not quite sure if I did it for the wrong question. Will this be saved on YouTube? I'm not quite sure, but the videos are recorded, so I think they will be made available for people to watch.
Yes,
So yeah.
it should be on
What I
YouTube.
will do, guys.
Sorry about that.
Sorry, Andres.
Yeah, so yes, they will be on YouTube. I'll upload them tonight. So tomorrow morning when you wake up, you should find them on YouTube and on the app when you look at past live lessons.
Okay. Okay, so they will be made available. Guys, what I will do, I will try, I'm not sure, Andres, if maybe there's a way that I can make these slides available. So for every lesson, I will make slides where we post, I will make the summary of the notes of whatever content we're going through, pose the questions, and then the answers to the questions right below that. So is there a way that we can make that available as well?
Yeah, so I'm gonna put them on the notes section on the app.
Okay.
So you go in, I'll say live lesson notes, and then that's how you'll know.
Okay. So from our next lesson moving forward, I will try and make my notes much more easy to read. So even after for if they just want to go through the notes, they can logically follow through and then see what we're doing, see the solutions to the questions we have, also the summary of the content that we're doing, and then so on and so forth. So for our next lesson, I believe which is on the weekend, I'm going to go through series. Series is what you guys started doing this year, I believe, in matric. So this was a revision of patterns and sequences, which you guys did. It's grade 11 content. But then again, I did say that the reason why I want to go through it and make sure that we solidify our knowledge was because it does appear in every single prelim and in every single final. Okay, so it's both patterns and series. So sequences
Sorry,
and
sir.
series that show up. Yes?
I wanted to ask for number C. Can you use completing the square?
Number C. Let's go through C quickly. You could have. I think it's possible, but I wouldn't, that would take much more time than you need. I think just a simple inequality would be sufficient for you there. So I like that you thought about that, because that is thinking outside the box. But you really didn't have to.
Okay, thank you.
Okay. Does anyone have any other questions on the content that we've done today? Maybe a question that was a bit iffy, or people didn't really understand what is going on. I do think that this is quite a nice section, guys. Sequences and series, it's a nice section. I think it's always the second question of your paper one, and it's always a nice question to bank easy marks, because the questions don't really deviate that much, except for maybe the higher order questions. But majority of 95% of the questions will be similar style. All the questions that we've done today, I took from past papers. So I think this was a mix of the 2023 and 2018 matric final paper. So these are the kinds of questions you can expect in your prelims. These are the kinds of questions you can expect in your finals as well. And you can see that for majority of the questions, if you know your formula, you know what each sequence means, what it represents, you'll be able to answer the questions and you'll be able to get those marks. Okay. Okay, any other questions, guys? Okay, I don't think we have any other questions. Okay, thank you very much, guys. That is it.
Please, sorry.
Yes.
For number C, you said you ufaguti term 91. Where did you get that term 91?
Atsimbo. See, term 91. Good Ngendao.
You on your solutions. Maui Lungis. Yeah.
Okay, where are you seeing 91?
Okay.
Is everything
Oh,
okay? Yeah, I understand.
yeah, I understand. That's right.
Okay, sure. So in things of guys, what I'm gonna try to do is I'm gonna try after this, maybe take some time, clear up the notes a little bit, and then we can upload them for you guys. So I will edit them properly so that you can see, okay, what question is this for, so on and so forth. So you can sit maybe afterwards and look at it for a couple of minutes and then understand if everything is the way you want it. And then what we can do, guys, is the beginning of the next session, maybe the first 10 to 15 minutes if you want. If you go through our session today and you feel like there's something that I went through and you didn't understand, but obviously you don't have a question now, if you have a question, you can ask me at the beginning of the next section. So we can do that with our sessions. The beginning, the first 10 minutes of each session is Sienzai. You can ask me any questions that you have on our previous session, or any question you have on a question that I did in our previous session. Yeah, well, so we can make sure that everyone is on track. Because what I'm doing is I'm going through the syllabus the way it's going to appear in your finals. So question 2, sequences and series. Question 3, I'm not quite sure what section question 3 is. I think it's functions, and then finance, probability, etc., etc. And then we can do the same for paper 2 as well. So this is paper 1 content. Okay. Are there no more questions, guys?
All right. No, thank you so much, guys, for attending. So all the material, like we said, is going to be available on the app and our YouTube channel. But don't forget to subscribe. And I'm not sure if you're part of that WhatsApp group. And if you're not part of the WhatsApp group, I'll just link it in. Then you can find it here. And then that's where we do all the important announcements. So the next lesson for maths is going to be on Saturday. And then tomorrow we have life science. So yeah, and then on Saturday we have 3 subjects. We have maths, accounting, and life science. We're going to start with physics soon. So yeah, look out for that. But yeah, no, thank you so much, guys. I will post the link into the WhatsApp channel as soon as it's there. So you can find the WhatsApp channel here on the chat. Then yeah, do join before I end because I think the chat is going to disappear once I end. Yeah, no, thank you so much, guys. And looking forward to seeing you again on Saturday.
Thank you, guys. Thank you.
Say, ngicela ukubuza on the app, why for life sciences, why is there like no content for evolution?
Okay, I'll just double check. Maybe the teachers didn't record it, so I'll make sure. Is evolution part of the matric syllabus?
Yes, and it's 54 marks for paper 2.
If that's the case, then I'll just double check with the life science teacher then, so that they can record the videos for that. And then
Okay,
I'll upload them accordingly. Thank you so much for letting me know. Right?
thank you, sir.
If you have other issues with the app or anything, you're welcome to WhatsApp me at the number that I'm gonna put in there, or just click that need help thing, then I'll get your numbers from there. Then I'll WhatsApp you and then we'll talk on WhatsApp. But guys, we're here for you guys to pass. Support you guys. We just want you guys to excel in terms of your subjects. So please feel more than welcome to reach out to us anytime you're stuck.